This is a test that I hadn't given before in here, and so you guys pay attention close. What I mean is, this is the first time that I've, these tests out of this particular book have been done. So we're going to start with jumping right in here to number one. Question number one is, a common point is a point where two or more wires are connected. That's true. That's actually true. A common point. All right. A location code is a code that indicates component position on a wiring diagram. Pretty much. Yeah. That's according to. If you find a connector or a component that you need to go to physically on the car, you're going to have to know where that is. Sometimes it'll surprise you when you find out where it is, I mean, like sometimes you'll think, well, this ought to be over here somewhere, and then you'll find out it's way yonder somewhere else. And there was a Saab, S-A-A-B, right after I came here. This girl came from the upholstery department over here, and she says, my Saab don't start. Sometimes it just won't start, and it spins and spins, and it just won't start. And so I pulled up the schematic and I had a look at it, and so I said, okay, I see where everything is and what feeds this and what feeds that. So I went over there, and she had no power to her fuel injectors, no power at all to spin it over. So pulling up my schematic that I had printed, I said, okay, that's coming through this pressure switch. It's hooked to the manifold, and it's a turbo. So what they deal was, they said if you overboost it, they want to kill the fuel injectors. If you've got an overboost condition where you're getting too much boost, they don't want to destroy the engine. So they got a little switch that whenever the boost pressure goes over a certain amount, it kills the fuel injectors. It wasn't too hard to figure that out, And so I go to that switch, I bypass it with a little jumper, I get power to the injectors, and it fires up. Boom, everything's fine. But the problem was, on that Saab, that 88 Saab, it said that it was down behind the fascia. Okay, now when I say fascia, what are you thinking? Huh? What are you thinking when I say fascia?
I'm thinking panel.
That's probably some the front where there's something connected to the front.
That sounds right. I mean, the bumper extension, they get like a ground effects package or something. That's what I'm thinking. I mean, I'm like you. I'm thinking fascia. It's just, we got language issues going on here, but yeah, this is a fascia. So I'm digging around down there behind where the fog light ought to be, looking for it down there. I ain't found nothing down there. Like, the book has told me it's down there behind it. It doesn't give me a picture, it just shows me words, right? And so I said, well, that's a bunch of hogwash. I don't see it down here. So I'm going to follow the hoses. Oh, here's a vacuum hose going into the engine compartment, into the passenger compartment. Let me follow that. And up there above behind the kick panel, which is what we would call that piece of plastic like you had to replace on your truck, behind the kick panel, I find this little white switch with 2 screws. That's how I located it, to bypass it and get the car going. All right, so I told the girl, I says, you've got to get one of these. And I don't think I can get one in op. Okay, hold on a second. Hello. Hey. What does that mean? What, oh, terminals? Just give me a box of them, Brett, you know that. All right, and I don't want to pay $80 for them, okay? How much a piece are they? Well, you better find out before you throw me a bill. All right, do that. All right, so if you don't tell him that, he's going to have trouble. Anyway, the long and short of it was, so I told her, I said, you need to take this thing and go to, and the reason I'm telling you this story is because component location is everything, right? So she goes home and she tells her mom, she says, the automotive instructor got my car started, and he tells me this part here is bad, and that's what we need. It was a little, I don't know how much it cost. It probably couldn't have cost over $25, $30, So she says, no, sir, we're going to take this car to the Saab dealer in Montgomery where they know what they're doing, but we're not going to pay any attention to what this guy down there at the school said. So she takes it up to the Saab dealer in Montgomery, and they put a fuel pump, an engine controller, a wire harness, and it's just like it was. Still won't start. They spent $3,000. And the girl was talking to the mechanics, and she says, guys, I'm telling you, all you need to do is look in there behind the kick panel. There's a little white switch. That's all that's wrong with it. They said, that switch is not behind the kick panel. It's down there behind the bumper. See, they didn't even know where it was. But if you don't know where the thing's located, you can't troubleshoot nothing. You got me? That's the long and short of that. So anyway, location code's a code that indicates component position on a wiring diagram. That's right. That's T, which is basically find out how to learn where things are, or so you can go to the connector, go to the component, and check your wires. A case ground is a remote point where two or more grounds are connected. No. What's a case ground, guys? What would you call a case ground?
Where the actual components grounded to the case.
Yeah, if you've got a controller or sometimes you'll have a relay. Believe it or not, sometimes you'll have a doggone relay that's actually got a little bracket on it, and that relay will be the ground for the coil on that relay is going to be through that bracket. So that's a case ground. Or if an engine controller, sometimes it'll have a case ground that actually where the housing on the controller is grounded to the body, that's called a case ground. So that's faulty there. Number 4, LTGRN is printed next to a wire on a wiring diagram. That's the color of the wire on the vehicle. That's true. Now, you better find out, he's telling me how much these terminals are. Hello. Well, how many are in there? Oh, 5. Well, they're $10 a pop. Wow. Okay, well, send me those. I'll have to charge the tar out of people whenever I put them on there, I guess. But you need to have some of those in stock because Stewart Automotive wants them occasionally. You know that, don't you? All right, there's no excuse for you not having some in stock. All right, you need to buy a box and just sell me one when I need it, okay? Oh, please. You're the boss, man. You just tell Ronnie that we're going to demote him from doctor to nurse or something. All right then. Please. All right. Solder on battery terminals. You can get them for about $3 a piece online. You know, 10 of them for $30 or something like that. You know, like in battery terminals we put on there. Lundy, you know, the one we were put on the other day. Yep. They're about $3 a piece online. They're $10 a piece the way he's buying them. And sometimes he has to borrow one from me because Stewart's will need one, and he don't keep them in stock. Get me? But I imagine he manages to get one to replace the one he borrowed from me, but now he's wanting me to buy a whole box. Big deal. Okay, so let me see, that's true. Number 5, electrical wiring diagram gives the exact location of electrical components on the vehicle. Well, that's false. The actual diagram doesn't tell you where the stuff is. And I'll tell you something else an electrical diagram will do. You'll see a little, and I could show you this in a couple of places. You may see a switch or something right here, and you may see a wire this long on the ground. And that ground may run from the front of the vehicle all the way to the back. Just because it's short on there don't mean it's short on the vehicle. However, if it's the only wire that's running from this point to that point, it'll just have one solid line. If, however, most of your wiring schematics, not all of them are the same, if it's running there, if it does other things and they don't want to have to show you everywhere else it goes, it will be broken like that. See that? It'll have a little broken, it won't be broken. What that's telling you is it's actually hooked to there, but it goes other places too. Now, why do you need to know that? If you're running another ground, let's say, you know, you got some, maybe that one is shorted to power or something like that, and you clip it out and you just ground this, and a bunch of other stuff may go offline because you're not feeding that. So you need to watch for stuff like that and be able to understand it. And it's easy to miss that if you wind up with myopia. You know what myopia is? It's different from utopia. You know, that's when you can only see this one little thing you're thinking about, right? Anybody ever got the can't see the forest for the trees syndrome? Okay, well, look here. All right, let me see here. That was number 5, wasn't it? Number 6. Technician A says Metripack connectors have push-to-seat or pull-to-seat terminals. Technician B says pull-to-seat and push-to-seat describe the method used when installing the terminals. Now that is C. Believe it or not, there are some of the terminals that you have to poke the wire all the way through the connector, and GMs are like this, some of them. You got to poke the wire all the way through the connector, attach the wire connector to the, you know, solder it or whatever to the wire, crimp it, and then pull it back to click it into the terminal. And if you don't know about that, it'll confuse the tar out of you because you'll be trying to pull it out this way and it ain't supposed to come out that way, you know. And the ones that I'm thinking about, even on these Power Stroke diesels, the ones that connect to the, for years it connected to the injector control pressure regulator were like that. you know, and also the one that connected to the ICP sensor. You know, they would actually have to come out. They were that way, but you know, you have to release them and push them out instead of pulling them back in. And that was totally foreign to me the first time I ran into it. A wiring diagram illustrates 3 wires that are joined together at C215. Connection A says the wires are connected together at connector C215. Technician B says the 3 wires are part of circuit 215. Who's correct about that? Yeah, that's an A rather, an A. And number 8, which of the following is not used to protect the circuit from too much current flow? Fuses, bus bars, fusible links, or circuit breakers? What is a bus bar?
That's just a little thing to hold it.
No, not really. Well, a bus bar, what you'll see bus bars occasionally, is going to be a piece of metal, I guess right here, that's got several places. Well, this is actually a metal thing. All right, and you're basically going to have a whole bunch of ground wires going to this and hooked to a major ground wire. It's hooked to, you know, the frame. It's a strange thing, but you're gonna, if they want to have a whole lot of, like if you've got 5 or 6 grounds that you're going to run to the same thing, having 5 or 6 grounds going under an eyelet on a post is kind of dumb. So basically, they just have a bus bar, a metal bus bar, and these things, it'll be crimped just like wire terminals to those. Now this will a lot of the times be in a plastic piece or something like that, so that you're not just looking at a comb-shaped piece of metal. But they'll have the screw and all grounded into the frame, and all of them are hooked together like that. You know, they usually have one over there too. So you'll have a bunch of them. That's a bus bar. It's not there for circuit protection. It's there so you can hook a bunch of other stuff up. Let me tell you something else. Sometimes coming out of a computer, listen to this now. It's important. You may have even seen this on a wire schematic or on a vehicle. Coming out of a computer, you'll have 2 wires that are hooked together that are feeding something coming out. Now, why in the world would they do that? 2 wires hooked together, and they're going to whatever component it is. I mean, they'll actually be just connected right here to that, coming out of this controller off that board. The reason they do that is because they're trying to pull something like a fan motor or something that's heavy and hard to pull. And they want to make sure that there's enough current able to flow out of that circuit board, so they got 2 connections to that circuit board there to carry that load. If you've just got one, then it'll start to heat up and burn things up. You got me? All right, so that's an important thing to do. You may see that, you'll usually see that with a power side, on the power side of stuff. But if you see that, you'll know why they did it that way. An operative radiator fan. What? I think they spelled that wrong. It says an operative radiator fan needs to be repaired. If it's operative, why the Sam Hill does it need to be repaired? Technician A says a single circuit type wiring diagram would be the simplest diagram to use. Technician B says component locator will probably be needed to repair this circuit. You know, that's a really screwball question right here, but I'm going to say that's supposed to be inoperative, and C is actually, you know, they basically should have said inoperative instead of operative. That was a error. And I did not type this test, by the way.
Hey, man. Can I talk with you real quick?
Not when I'm in the middle of a lecture. Come back in about 45 minutes.
Alright.
Right. Okay. Alright, let me see right here. What's the best place to find the location of a blower relay?
What type of blower?
Huh?
What type of blower?
You know, he reminds me of this guy that the computer science instructor told me. She said she had this guy in her class, and she says she's trying to get him to wrap his head around a concept. It had to do with computer programming or something. She said, let's say that you had bought a 6-pack of beer that cost $18, and you wanted to sell me one of those 6-packs of, one of those cans of beer for what it cost you. How much would it be? And he says, were they 10-ounce cans or 12-ounce cans? That's the kind of question he just asked, right? Okay, now, Joe, where is the best place to find the location of a blower relay? Now, you've got 4 choices, and your question is not pertinent to either of these choices. What kind of blower are you talking about? Doesn't matter, okay? A, wiring diagram manual. B, component locator. C, connector locator. D, ground locator.
Is it C for resistance or relay?
No, B.
It's actually going to be B, component locator. You're going to go to your component locator. Now, one of the things that annoys me sometimes on in some of the shop manuals, and even in all, and all data basically comes out of the shop manuals, you'll find a place where there's nothing but words, and it'll say left side of engine compartment near master cylinder. That sort of narrows it down, but I'd rather see a picture. You know, I want to, you know, so I can look at that. Technician A says wiring diagrams give specific circuit information in detail. Technician B says a wiring diagram will help you find the fault. And that's just a no-brainer there. That's C. What usually causes a fuse to blow? Huh? Too much voltage, too much amperage, too little voltage, or too little resistance? Huh? Now, what usually causes a fuse to do this? To burn up. This fuse here burned up. Came off of that 2004 Sebring that's been sitting back there. It belongs to NERMI. The cooling fan got to where it wouldn't work. Did you know a fuse can melt like that without ever blowing?
I got one. It's still in there though.
Yeah, I mean it melted the fuse, but it didn't blow the fuse.
Didn't blow it.
So what in the world is going on there? I mean, why is it melt? Basically, you wind up with resistance and oxidation there, and it starts to heat up because of the resistance, and it can actually, the resistance is keeping the current from going up high enough to blow the fuse, but at the same time it's melting things. You know, because anytime you got resistance, you got heat. I had a Chrysler instructor one time that tried to say resistance didn't make heat. Everybody in that class rolled their eyes, but I took him on. I said, that's hogwash. Why do they make resistors out of ceramic? I mean, because of heat. You know, he finally had to back off. Like, well, yeah, I guess it does. I don't know where he came from that. But every mechanic in that room knew he was silly about that. You know what I'm saying? You ever heard somebody say it was just dead wrong? I hope you guys will call me to task if I tell you something ain't right. You know what I'm saying? You should. I may say something that's not right just now and again, see if you're paying attention. That'd be good? Okay. I'll say up is down or something like that. And y'all supposed to say, huh? What? What are you talking about? Okay. Let's see. Technician A says two connectors with the same number are physically the same connector. Technician B says the two connectors are drawn apart so the drawing is easier to read. That's basically C. If you see two connectors on a wiring schematic, if it says C251 and it says C251 and it looks like they're two different connectors, then what they're trying to do is make it so the lines on that wiring schematic are not crossing one another. You know, it's really, sometimes it's really, really hard to do, but they don't want to cause them lines to go cross one another because that really confuses you.
So it was 12.
Oh, we missed 12? Well, what usually causes a fuse to blow? You should know that. Too much amperage. A fuse is basically, what's a fuse rated for? What's that number on a fuse mean? Okay. All right. So, incidentally, you see that schematic up there underneath that code chart thing? That schematic right there is the entire vehicle wiring schematic for a 64 Chevrolet. The whole thing, start to finish. Right there. If I can match my laser, see that? Right there. That's the whole wiring schematic for a 64 Chevy. And that's something?
That has more wires on it than the 70 bus I got. I have the whole one for it. It's got like 10 wires.
Yeah, there's not many there, you know. It didn't get all that hard back in them days. All right. You might look at that schematic sometime when you have time. It's pretty interesting. And you can figure out what it is because they got the stuff drawn, you know. The distributor and the headlights and all that are drawn to look like what they are. Okay, let me go right here. Number 14, Technician A says twisted/shielded wires carry low current and repairs to the wire must not increase the resistance of the circuit. Technician B says twisted/shielded wire carries high current and any repairs must not increase the resistance of the circuit. That's 14. That's A. Anytime you see twisted/shielded wires, they're basically carrying a really delicate signal from point A to point B, and whenever the signal is shielded, what's shielded mean? What's a shielded wire? You seen a shielded wire before? Huh? Look at the one on that crank sensor on that ignition board. See those two wires going from the crank sensor down to the engine controller representation? Those wires will have foil wrapped around them. They'll be twisted around another. They'll have foil wrapped around them, and they'll also have a wire that's sort of wrapped along with, you know, like kind of, they lay a wire along next to them, wrap foil, so that wire is touching that foil all the way up and down, and they ground that wire, and that prevents electrical interference from getting in there. You got me? I just put that poster up there. But anyway, so what happens is, when the Explorers first came out with that kind of crank sensor in 1991, they had a problem with some of them cutting up and not wanting to start, because in spite of the shielded wire, they had routed the crank sensor wire right next to the doggone negative starter cable for about a foot or something. And when you go to spin the thing over and fire it up, all of that current flowing through there was inducing stuff in that wire, and it would cause it not to start. And so all we had to do was just reroute that wire away from there, so we don't want to induce anything in that wire. So anytime you see wires that are twisted around one another, particularly network wires, if you have to require that, fix a circuit, you're going to have the same number of twists per foot as they had before. You don't just fix them and let the wires stay apart. As a matter of fact, there was a Dodge, and I don't remember what the problem it was having, a Dodge pickup that came out in the late 90s, early 2000s, that had a network wire that was going from this smart junction box over to another controller, and it was doing crazy things. I can't remember what it was doing, but the way that the CSB came out to fix that was said to disconnect the wires from one end and put more twists in them and hook it back up. Now, you get the significance of that? See, if I don't stop to explain this kind of stuff, you're going to be sitting here saying, well, I wasn't taught this in school. I don't know about this. How come I don't know about this? See, I'm remiss if I don't tell you everything that I can think of that's pertinent, because them little niceties there keeps you from putting a lot of parts on one they don't need. Okay, so number 15, Technician A says the VIN number will help determine the correct wiring diagram to use for diagnosis. Technician B says each automobile model may have a different wiring diagram. Well, that's no no-brainer there. And then let's see. Tell you something else too. There's nothing that will irritate you more than having a wiring diagram that's wrong. And it can be published from the manufacturer wrong. And they have to periodically release updates to that. And fortunately, they're online now, so they can do it real easy. When they used to be in books, it was a booger bear. Let's see. Technician A says stranded wire has more resistance than solid wire. Technician B says there's more surface area exposed in a stranded wire due to electron flow. Who's right about that? That's B. Because of the fact that you got a lot of little bitty wires, you collectively have more surface area on that than you do something like a piece of 12 Romex, you know, like you'd use in your house or something like that. Let's see. Technician A says the effect of temperature on resistance is a factor in wire size selection. Technician B says wire must be large enough to carry the amount of current necessary for the circuit to operate correctly. Who's right about that? That's going to be C. If you've got a bunch of lights right here, let's say you got this light and that light, okay, and this light. And let's say that, and this is a parallel circuit, right? All of this is going through a fuse. All right, and then you got a switch. All right, if these three lights right here are actually each going to pull 3 amps. Got me? Let's say they're going to pull 5 amps. 5 amps each. 5, 5, 5. What should this fuse be?
20 amp fuse or 15?
Yeah, 20 amp is better, because when you first turn them on from electrical 1, you should remember that these bulbs have got less resistance when they're cold than they do when they're hot. And so if you looked on a scope, when you close that switch, your amperage is going to go up, and then it's going to level off. So you got to have a fuse that's higher than that surge, basically. If you put a 15 amp fuse in there, it's probably going to pop it every time you turn it on. But if you put a 20 or a 25, it'll actually If you have a short, it'll blow the fuse, but you know, that's an engineering thing, but you need to recognize it is important to have the right, you know, one in there. All right, now then, switch is drawn on a wiring diagram with NC printed beside it. What does that mean? Normally closed, that's right. Give me an example of a normally closed switch on a car. What about it? How about the door jamb switch? You open the door, the button comes out, it's lighting up your interior lights. So when it's at rest, the lights are on because you got the door open. When you close the door, you're mashing the switch and it's opening up. See? So you got normally closed and normally open switches. Technician A says a common point is represented by a black dot on the wiring diagram. Technician B says a connector could be a common point. Both of those guys are right about that. Black dot on the wiring diagram. I could use my thing. You've seen this right here. See that? You got that? You got them hooked together. You've also seen a connector on the wiring schematic. Like you got a box here, and you got wires coming in here. And you may see a wire coming out of there, wire coming out of there, and then you'll also see one coming out there. That means both of those are hooked to the same terminal in that connector. They're making a junction point of that connector instead of soldering them together somewhere else. Now the good part about that is, if you've got them this way, you know where that junction is. Got me? If you don't have them there, if you've got a splice or a common point, it can be in that harness, you know, it'll say, when you're trying to find that splice, you can find splice locations, but it'll say, you know, near tape out to instrument cluster, near T/O or take off or tape out or whatever you want to call it. And that way you got to go up in there behind the dash if you're trying to inspect that splice and split that harness open and go and find that splice and see if it's corroded. You know, usually when they corrode, it's because the thing's been wet, or maybe it's running under the carpet and somebody's left the window down a few times or something like that. All right, now let's jump on through there to Technician A says, let me see, never mind. Technician A says troubleshooting is a step-by-step process of elimination of cause and effect. Technician B says troubleshooting is a diagnostic procedure for locating and identifying the cause of the fault. Let's make a little C there. Cause and effect, basically, if you're looking to try to find out. Effect is what your symptom is going to be, right? When you're trying to find the cause of that symptom, you got to dig into that. Technician A says crimping solderless connections is the best method of splicing wires. That's number 21. Technician B says crimping should not be used if the connection is subjected to excessive movement. Now, I will tell you one of the things that I always didn't understand. When I fix a wire, I like to solder it. Daniel likes to solder too, by the way. But sometimes from your manufacturer, they will send you a set of instructions and they'll tell you to strip your wire really long like this. And then they'll tell you to strip your other wire really long and twist them together. Just twist them together and then put a piece of shrink tubing over it. Now, I've never liked that. I don't know why they do it unless some people don't know how to solder or something. You know what I mean? So that's just a strange thing. Or it seems to me like they maybe fold it back or something. The reason I never memorize that because I ain't gonna do that. You know, I'm gonna use a solder gun and I'm gonna make it right. You know, but they were just wanting to make sure that you didn't have it just barely tied together and taped so it would pull apart. You know, that's basically all they're saying. They want you to, if you're gonna tie it together, you need a lot of wire touching each other. Basically, what they're saying. Technician A says wire harnesses pass from the passenger compartment to the engine compartment through bulkhead connectors. Technician B says wire harness is a group of wires that branches out to various electrical components. That is 22. What you got there? Let's see. However, how many of you have seen on a Chevrolet wiring schematic, on a General Motors wiring schematic, something that looks like And I may not be drawing it exactly right. You'll see that on GM wiring schematic. And what that means is that wire passes through the bulkhead. That's supposed to represent a grommet. You know what I mean? So GM will run them through the, you know, for years, we'll run them through a grommet like a lot of them would. But they were good enough to let you know if you see a line of grommets there with wires going through them, basically what you're going to find out there is you're going to find out that
Here's on deck.
what you're going to find out is that if whatever you're looking for is on this side of the grommet, it's in the engine compartment. Like if it's the power distribution center feeding something on the inside of the truck, if you see them grommets there and where the origin is out here in the engine compartment, don't look out there for what you're looking for. If it's on the other side of these grommets, it's going to be inside. That's really important to know too. So number 23, ground straps are used to do what? Provide a return path to the battery between insulated components, suppress electromagnetic induction, both A and B or neither A and B. Now let me ask you this: have any of you guys seen these these funky ground straps or whatever devices that ground the hood of the car? They have a little thing sticking up with little scratchy things on it, so that when you close the hood, it scratches against the hood. What in the world are they worried about the hood? Being grounded for. It ain't gonna, even if it ain't got no light or nothing on it, they'll ground the hood. Usually either with a braided ground strap or a, something that will scratch instantly when you close it. You suppose it might have something to do with the hood making static electricity? They want to make sure that, that doesn't have any sparks because of that, because it's a big piece of metal, right? Helicopter rotor blades, I was talking to them the other day, they chop up static whenever they're wheeling around. You see them at night. Makes it look like flying saucers out there. You all seen that, you combat veterans. You see, if you're looking at night, you'll see strange halos with them helicopter blades. Well, the hood of the car is going to do stuff like that too. It's going to make, so they want to make sure that that's neutralized. Now, if you disconnect those, I don't know what's going to happen, but for some reason they think it's a big deal, so they ground them all. All right, now then, something else. Let me say this. This is really important too. You may find yourself in a situation where you have to ground the engine to the frame for whatever reason. And if you put a stiff ground wire between two things that are going to be moving, then you're going to have issues. And the reason I'm saying that is, if you got a stiff ground wire going from the engine to the body of the car, it's going to carry sound. That's one problem. Like if you get like a stiff piece of battery cable and put lugs on each end, every time that engine moves, when it torques a little bit, it's going to bend that a little bit, and one day you're going to open the hood and you're going to see it's in two pieces. Now I've seen that. Motorhome manufacturers used to build them. They'd put a great big old double aught wire about this long going from the engine over to the frame. Make sure you're grounding the frame. And you know what kind of a symptom that would cause? The people that own the motorhome would come in and they say, when I drive off, my temperature gauge gets up all the way to hot. It kind of goes with my speedometer, and then when I slow down, it comes back down. And every time on the right front corner of that thing, I could look and there'd be a broke wire. And what I'd do was I'd get a piece of braided ground material that I'd get from somewhere, and I would use a braided strap that was really flexible, you see. That's how you do that. That's why you have flexible ground straps like that, so you're not carrying noise and they don't break whenever they wiggle and all that. So keep that in mind too. Two technicians are discussing a shielded wire repair. Technician A says shielded wire must be kept separate from the circuit wire. Technician B says there's no difference between repairing a shielded wire or a non-shielded wire. That's going to be A. The wire's got to be kept separate from the circuit wire.
What was 23?
23 was basically, what did you figure out? C. It's going to be A and B. They're going to suppress electromagnetic induction and provide a return path to the battery between insulated components. And that ground stuff, there is one, I have seen situations where, if you, listen to this guys, if you turn on one component and a bunch of other components fire up, be looking for a ground. Like if you turn on your headlights and you see other lights coming on that aren't supposed to be on or something like that, that's usually going to be a ground. Now, there's a caveat to that. What if I told you that I was when I mash the brake, my dash lights come on. I've seen that. I've seen it happen. People come brought their car to the dealership, have it written up in the service right there. When I mash my brake, my dash lights come on. I'm talking about my instrument cluster illumination lights. So what's wrong with that?
We've had that in here.
Or we've talked about it. See how easy it is to forget? Huh? That's a bad bulb. A bad brake light bulb. You got two filaments in there. You got a stop light and you got a tail light. And what will happen is inside one of those bulbs, those two wires that are feeding those filaments are touching. Now when you turn on your headlights, you know, and your dash lights come on, there's going to be some issues there too. But the one you most notice is the one that when I mash the brake and I don't have my lights on, I see instrument cluster light up. Or if it's got one of those little clusters, it's got the little green numbers in it, they'll go dim. And that's it. So somebody came over to me and was driving them crazy. What am I going to do about this? I said, take out all your stoplight bulbs and just see if it still does it. So they pull all the stoplight bulbs out, poof. You know, so one of them stoplight bulbs is bad. When you find it, you put it in there, it'll be okay. They've been scratched around, worked on it, you know. Sometimes you just got to think clearly, you know. What's the easiest thing to check first? That's what I'm always looking for. Go to the easiest point first. All right, let's see here. Technician A says the wiring diagram is an excellent tool in locating circuit failures. Technician B says in most cases the wiring diagram is not necessary to locate circuit failures. Who's right about that? A is the only one that's right about that. I'm going to get me a wiring schematic. I am definitely going to do that. If you ain't got a wiring schematic, you're hamstrung and crippled. Here's a guy this guy sent me you guys parse this for me. This guy sends me an email and he says my Escort will spin and spin and spin and spin, and it's got a new battery in it with the key, but it's a standard, and when I push it, it will start up as soon as I pop the clutch. And I can drive it around, but if I switch it off, so give me a possibility, somebody. We got to be able to tell this guy what to do now. He's stranded in the desert, you know.
So
he spins it with a key, and it spins normally. It spins fast, good voltage, but it won't start. But if he pushes it, you know, puts it in first gear, pops the clutch, boom, fires right up. No problem. Think about that. That's a mystery, isn't it? What's the first thing you're going to tell the guy to do? Now, wait a minute. This guy's depending on you for answers, and this may depend on whether you get that $20 an hour job or not. You know what I mean? This is a true story. This guy sent me an email this weekend. Huh? When you're spinning it over, it spins, it spins, it spins, it spins. What I told the guy to do, I've seen this before on various different cars. And if you take, the first thing I'm going to do, because it's cheap and it's quick and it's easy, is you get your jumper cables and you hook it to the ground side of the battery, and you hook it to a good secure block ground. See if it'll fire up that way. If it will, you got a dirty connection at your engine block. Believe it or not, it can have enough of a connection to spin the starter, but it can create enough electrical noise to confuse the ignition system and the spark output part of it. And I saw that on a big Bronco, like the one we got out here. It drove me up the wall. And I was, you know, I'd spin it over, and when you pull the spout connector, you know, the little spark output connector for setting the timing, it would fire right up. But when you put that back in, it wouldn't start for love or money. And I hooked the service bay diagnostic system to it and got a trace on the ground. And when you were spinning it over, that ground was all over the place. Now, it was spinning good. See, where we're going at. And there's other things you need to consider too. How much voltage is the engine controller actually seeing? Let's say I'm seeing 11.5 volts there when I'm spinning, but because of voltage drop considerations or whatever, maybe in the power relay, I'm only seeing about 8 volts at the engine controller. You know, with the starter spinning. It's below that threshold. It's not going to operate the fuel injectors, is it? There's a whole bunch of ways you could go with that. It'd really be kind of fun to get your eyeballs on that one so you can figure out what's going on with it, you know. Here's another one. This is a little troubleshooting exercise, and we may see this truck here. My pastor's wife came and she said, I work with a guy, and he's got an F-150, and he keeps 2 quarts of oil with him all the time because it burns a quart. He said it gets rid of a quart of oil every couple of days. It's not smoking, it's not leaking on the ground. Huh? Has to be coming out the tailpipe, ain't going on the ground, but he ain't smoking. But there's a lot of oil getting gone. Think about those possibilities. We may get a chance to see that one. And if you can't figure it out, you're fired. Okay? That's how it works. All right, now then, let me see here. Where are we at? What does a symbol labeled G200 in the figure below indicate? We're looking at G200. G200.
What is that? Is that growing thing?
No, not on this. They're not going to have a thing. Yeah, that's basically going to be a ground, the place where the ground connection is. G200. See, they're trying to make you get tricked, I guess, because they got an arrow point to it that says common ground. Give me a break, you know. But you also got a common connection there that feeds a lot of other stuff. All right, now let me hit you with this. Let's say that you've got a some interior lights that don't work. I've had this by myself before. Interior lights that don't work, and there's a splash like this, and it's feeding every darn thing. I mean, it's got grounds going all over the place. And so you're basically looking at trying to figure out why it is that you got one thing that don't work. You know, how are you going to track that down? Think about that. I'll throw you an exercise later. Why are stranded Cooper wires, copper, not Cooper, why are stranded copper wires, they put Cooper on here, I guess they mistyped it like I do sometimes. O and the P are right next to each other on the keyboard. Used instead of solid copper wire. We said that something about that earlier. Anybody remember?
Yeah, more surface area.
More surface area because you got a lot of little wires. That's what it is.
Less resistance than solid copper.
Okay, name 5 types of conductor materials. That's number 28.
Silver, gold, aluminum, tin-plated brass, and copper.
Wow, he's been reading the book. You notice how he knows the answers because he's been reading the book? That is smart, isn't it? That's a smart guy that reads the book, all right? Everybody take a lesson from that. If you want to fill in all the Swiss cheese, read the book, listen to me, and draw on your experience. Number 29, how is wire size determined? If I told you that, you remember what I told you about gauges? It's basically the size of the conductor, diameter of it. Watch this. If I got a wire that, let's say this wire right here, and it says 0.8 next to it on a schematic. What's that telling me?
8 amps.
No, we're talking wire size now. Forget about everything but wire size.
8 gauge.
That is 0.8 millimeters. That's how big that piece of copper is inside that plastic. All right. If it's what if it says 8?
8 millimeters.
8 millimeters. Unless, what if it was imperial gauges and it said 8? 8 gauge.
So you're saying wires are determined through millimeters?
No, not American ones, only metric ones. Metric wire gauges, the bigger the number is, the bigger the wire is. With American wire gauges, the bigger the number is, the littler the wire is. For instance, like if you got a 10 gauge wire that's American, and you got a 20 gauge wire that's American, the 10 gauge wire is going to be a big fat thing. You know, like what goes to your big post on your alternator or something like that. The 20 gauge wire is going to be one that goes to your taillights. However, if you had these same 2 wires, if it was metric, this one here would be 8, and that one there would be 0.5 or something like that. See? So know what they mean. If it says 1.0, it's a 1 millimeter thick wire. You see, so don't get crossed up on that. I'm telling you both of those so you won't be thinking.
So what you want the answer to be? The bigger the number, the smaller?
No, the diameter of the conductor. Diameter of the conductor is the right answer. And there'll be some of these kind of questions on your final too, so get used to these short answer questions. And I've also usually put an essay question on the end of every test too. That's good, ain't it? All right. 30, in the AWG standard, what's the relationship between diameter and the size wire? I just told you that. AWG is the smaller the diameter, the higher the number, the smaller the diameter of the wire. That's what I was just talking about. Number 31, what information is available to determine the exact location of electrical components in a vehicle? Component locator section of service information. The first group of letters designate the base color of the wire. I'm going to give you the answer. The next one is because in most wire color codes, what do the first and second group of letters on the wiring diagram indicate? The first one of them designates the base color of the wire. Basically, what we're talking about here is you're going to see something that says white, light green, something like that. This right here is the primary color of the wire. This right here is the stripe. The stripe's on the right side of that slash, right? On a Mercedes, what if you had a Mercedes and the wire was going along there and it had an SW next to it? What's that mean?
Black.
Yeah, because Schwartz is black, like your shirts, right? Got it? That's what that is. But you got to, the point is, you better go, and what did, Brown, what did I tell you represents blue on an Asian wiring schematic? L. L's blue on like Toyotas and stuff. All right. Okay. What effect will an increase in temperature have on wiring resistance? It's obviously going to a similar increase in resistance because it's what? Positive temperature coefficient. Wire is. What type of connection is used to pass large bundles of wire between the passenger compartment and the engine compartment bulkhead? Like if you're going to go through that thing. Usually bulkhead connectors, but sometimes they'll go through a grommet. So it's not always bulkhead connectors, although it should be. And number 35, how can a test lamp be used to locate a shorted or overloaded circuit? That's important. Very important. Okay, I've got a little fuse panel here. I'm just going to draw the one, and there's a fuse right here, right? Alright, and the little fuse has got this little stuff in here, and it is blown. Alright, so this is actually plugging into a couple of terminals in there. Alright, so I'm going to take my light, and I'm going to put it right here. Everything turned off, right? Everything unplugged. In other words, everything, like all of the lights that are connected to that circuit, everything that's connected to that circuit needs to be disconnected. Okay? We got that? Then, should that light be burning? No. If the light's burning, you got to short. That's when you're going to watch that light, and you're going to jiggle your harness, and if that light comes and goes, you found your problem. But let's take it a step further. Let's get, you know these little circuit breakers that have the little screw terminals on them? Those little square circuit breakers got 2 screw terminals on it. One of them needs to be a little longer than the other. I ought to have one in my hand and wave in front of your nose. What if I take that and I put that circuit breaker in there so that it's connected to that, and it needs to be like an 8 amp, you know what I'm saying? Very, very low amperage circuit breaker. And I'm going to take a little light bulb and I'm going to put it right here. I'm going to build me a tool. It's a freebie, almost. You got to buy the circuit breaker and find your light bulb somewhere. You go in there like that. That circuit breaker is going to click off and on. Ding, ding. When it opens up, that light's going to be burning. When it closes, that light will be off. All right. I put my circuit breaker in there. Let's say I'm looking at a courtesy light circuit. And you know what's fed from the courtesy light circuit? Your map lights, your mirror lights on your, you know, all of that stuff. And I noticed that when I put that in there and it's clicking off and on, I'm watching all those lights. If it's the lights, it's easier. If it's something else, it may not be. I'm seeing every one of those lights go off and on real dim, except the one in this particular sun visor that feeds the little vanity lights. What's that telling me? That tells me the leg of that circuit that's feeding that is shorted to ground. Got me? Well, now I know where my short is. I just got to, and if I want to do it quick, I can run another wire from the source to that particular vanity light. Maybe a little tricky in some deals, but that's how you fix it. That's how you find it. That's how you fix it. Everybody clear on that?
So that light is flickering.
That's light. It's actually that circuit breaker. When that shorts there, it's going to open, It's going to cool off, it's going to close. It's going to be about every second or so. Ding, 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 ding. Now do not, under any circumstances, take something like a 30 amp fuse and put it there, because you will burn up wires if you do that. You know, you'll destroy wires that way. I've seen that happen. But you want a really weak circuit breaker that will reset itself, like kind of a robust but not pulling a lot of amps. That's really, really important. Okay, and that's smart. Also, if you take something like a headlight bulb to check the veracity of a ground, sometimes a ground will burn a regular test light, but it won't burn something like a headlight bulb. That'll tell you the ground is too weak, you need to run another ground. I've got a YouTube video on that out there where we found that on that Ranger. It would burn the test light, but it wouldn't run the pump. And a headlight bulb burns about the same amount of current as a pump when it's pumping fuel. So I hooked a headlight bulb up to that circuit, and it wouldn't light up that headlight bulb, but it would light the test light. And that will confuse you in a big way. But make sure that you got something that'll pull enough current to find it. Explain at what point during an electrical repair would component splice, ground, and connector locators be used. That's really difficult. Everybody ready to write really fast? Locator manuals are going to identify the physical location of whatever it is you're talking about. They're supposed to be considered when the technician is ready to begin testing. For example, the voltage at a common point. If that's got to be checked, you've got to find that common point. If you're checking the quality of your ground connection, if you're performing the analysis of the input and the output terminals on an electric module. You know, so you're going to have to find which, not only are you going to have to find a connector, if you're looking at a connector, you got to find out which cavity in that connector that wire goes through. Okay? It's really important there. Now this was a kind of a long class session, but we had to do a lot of talking about stuff. It was really important. All right. So nobody should leave here dumber than when they came in, right?